One of the key roles that statistics is going to be able to play for us is the process of inference, or inferential statistics more broadly. And the idea with inferential statistics is it's the type of statistics, or it's sort of the overarching subfield of statistics, that's going to allow us to actually take data that we've observed, right, whatever the source of those data are, and use those data to make inferences or draw conclusions about a population of interest, right? So it's saying, how do we take these data that we can actually see, that we can actually observe, and how do we use them to say something of use to us about the population that we actually care about? So with inferential statistics, we're trying to use samples to make conclusions or draw conclusions about our population, right? So it's that linking up of connecting our sample back to our population. And so let's think about what we're actually trying to do with inferential statistics, right? We have our population of interest here, and the population is going to be containing sort of all of the individuals that we might think to care about, right? So every single possible option that we care about is going to be contained somewhere inside of this population. Now, we typically can't observe that whole population at once, right? And we also typically don't care about everything about that population. So instead of caring about everything about that population, we typically are thinking about caring about some specific parameter. So we want to know the average income, or we want to know the average height, or we want to know something specific about this population, right? If we could observe the whole population, this would be really easy. We could just measure that thing for everyone, but we can't, right? Instead, we take a sample, and we're going to be using that sample. The sample is what we actually observe. We take the data in from that sample, right? And by taking the data in from that sample, we can make estimates about what's going on. We can actually observe the different variables. We can compute something, right? And the thing that we actually compute are statistics. So we have our population. We want to know something about the population. We take a sample. Using that sample, we can calculate different statistics. And our goal is to use that statistic that we calculate to say something back about the parameter. Okay. And so connecting this all together is the role of inferential statistics, right? That's what inferential statistics actually sets out to do. Because of course, if you take a sample from a population, you're probably not going to get exactly the right answer, right? If I want to know the average height of Canadians, so I take a sample of 100 Canadians or 1,000 Canadians, and I take their average height, that's probably not going to be exactly the same as if I had measured every single Canadian, right? We know that we're not going to get the exact right answer, but somehow we want to still be able to say something about the average height of Canadians from that average that we can actually observe. And so inferential statistics is going to be what allows us to actually do that. So we can think about this at sort of the most broad level here, right? There's typically two goals we're thinking about with inferential statistics: estimation and then hypothesis testing. Okay. And so estimation is going to refer to the process that we're using data to infer guesses as to the parameter of interest, right? Or guesses as to what that value is actually going to be. So if we want to know the average height, estimation is going to allow us to guess what is that average height based on what we're actually observing here. So thinking about this sort of in a few examples here, in medical testing, we might want to know what is the average change in life expectancy for a patient that receives a particular treatment, right? And so here, what we're trying to estimate is how much does someone's life expectancy increase if they receive a treatment for their disease, right? Or if they receive a specific treatment for their disease, for instance. And so there's some parameter there, right? That parameter would be the increase in life expectancy for the individual. We don't know what that parameter value is, but if we take a sample and then we measure that in the sample, maybe we can use that sample to guess what that value is. And when we're talking about guessing it, right, we want it to be an informed guess. We want it to be an accurate guess. We want it to be precise. We want to be hoping that we're getting close to the real truth here, right? But it's a guess nonetheless. And so estimation is going to allow us to actually try to guess at that parameter value. Thinking about in conservation research, right? How large is the population of an endangered bird species? Again, there is some value out there that actually tells us the population of that endangered bird species. But in order for us to know that specific value, we have to observe every single bird of that species. And that's typically not going to happen. So instead, we observe some sample, and we get to observe some traits of that sample. And then using that information, we say, okay, so how big do we think that population is on the whole? What is our guess as to this? And we're going to inform that guess through the data that we actually observe, and we're using estimation to actually do this. On the other side from estimation is hypothesis testing, and hypothesis testing is going to refer to the use of data to assess whether evidence is contradicting some underlying belief about the parameter of interest, right? So we have some belief about this parameter, and we want to say, do the data support this belief, or do the data contradict this belief? Right? And so hypothesis testing is going to be the broad framework that we can use to address these types of questions. So if we think back to medical testing, right, we might ask, does the new treatment have a positive impact on life expectancy? And if you think about this, this is a subtly different question than the estimation. With the estimation, we wanted to know what was the impact. But here, we want to say, does it have a positive impact? Does it increase the life expectancy? And so we know that any treatment that we come up with, it may or may not have a positive impact on life expectancy. But we want to go out and make observations and then say, do the data that we've observed suggest that this is actually positive? Right? Just because it was positive on a few people doesn't mean that it's going to be overall positive. And so can we use those data to assess whether this looks like it's working or not? With something like conservation research, maybe there's two subspecies of this endangered bird species, right? So, or two different populations living in different regions. And we want to know, are the populations of those two subpopulations the same, or are they different? So again, this is different from us asking, how big are these populations? We're not trying to estimate how big they are, but we're trying to say, is the size of these populations really the same? Are they actually the same, or is one larger than the other, right? And so again, we can go out, we can observe data, and then we can say, based on the data that we observe, does it contradict this idea that they're actually the same, or does it contradict this idea that they're actually different? Okay, so then we're thinking through inferential statistics is typically dealing with either estimation or hypothesis testing. And in order to perform statistical inference, we're going to start by collecting data from our population of interest. This population is characterized by unknown parameters, right? We don't actually know the values, but we're interested in them. We want to know their values, or we want to ask questions about their values, right? Because we can't take all members of the population, because we can't perform a census, we instead collect data which constitutes a sample from the population. And the sample is either going to be observational or experimental, depending on the context that we're dealing with here, right? It doesn't really matter in terms of the overarching picture, but it's going to change exactly the nuances that we have for our interpretation here. We know that our sample is not going to correspond exactly to the population, right? If you take a sample of 100 people and you measure their average heights, that's not going to be the same as if you could measure every person and look at the height over every single individual, right? And so we know that the sample is not going to be exactly accurate. The uncertainty that's arising is going to come through different variations in samples, right? We'll think about this as being sampling variability. Depends on which 100 people you pull in, right? If you happen to get 100 people and they're shorter than average, then your sample is going to come up shorter than average, right? And that's just you getting sort of unlucky with a sample. Same thing if you happen to pull people who are too tall in the sample, right? You've just sort of gotten unlucky there. And that's always going to be possible. And so that variation is a natural part of the data that we're actually looking at collecting here, right? And so part of inferential statistics is accounting for this variation or quantifying this variation. And so what we're going to be doing with inferential statistics is quantifying that uncertainty or the variation that we have there in order to provide information about the population parameter of interest, even though we can't know exactly what that parameter value is going to be. Right? And so we sort of use that sample that we've collected, we acknowledge the fact that there's uncertainty in it, and then we use that to say something of interest about that population. So the fundamental difficulty that we're going to be trying to address here is the fact that when you perform sampling, when you take in a subset from a population, there's going to be sampling variability. Every single time you draw a sample, you would get different individuals, and so you'd get a different guess or you'd get different conclusions in your hypothesis test, right? And so what we need to be able to do is say, okay, that's a natural part of the process. How can we incorporate that into the conclusions that we're drawing, into the guesses that we're making, right? And by doing so, how can we then connect that back to the population parameters that we actually care about, right? So the process of inferential statistics is going to say, how can we come up with guesses to the parameter values, or how can we assess information about questions about the parameter values in light of this sampling variability, in light of the fact that when you take a sample, you're going to be at the whims of the individuals that happen to be included within this sample. And there's going to be a lot of techniques that we use in order to sort of accommodate for all of this type of variation, right? But all of those different techniques fall into the umbrella of inferential statistics.